We see a lot of familiar names today.
Oh, hi, Winnie. Hello.
Kel, did you manage to send out all your start kits, the winners?
Yes, I think only the last round. The last round, not yet. The rest are all out. The last round. Because I'm sorry to those who have not received. I think there's two or three addressees that we have not received. We have been too involved watching Netflix.
Squid Game, huh?
See what 3D printer can do, everybody. They were having fun with 3D printing. So Chris is the one that builds up all this craze. You know, that's I think that's the topic today. So with 3D printing is really exciting. I mean, I myself as a learner, as a newbie, so I learned a lot from Chris. What 3D printing can actually customize towards urban farming or towards a home, any kind of things that we want to build, whether it's a hydroponic set, whether it's something like a robotic arm, which we are going to build for one of the greenhouse in Sprouts Hub. So things like that. We can have fun like building stuff, like simple stuff like that. You guys see, we are so Netflix Squid Game crazy. So build stuff like that. So that's today's topic, 3D printing. Really, there's a lot we can do. Technology. I mean, basically, I look at that as a technology, artificial intelligence, AI technology, planting, farming. So I'm really very encouraged by the attendance that people are all interested in this. I think this is the future. So I mean, we are living in it today. I can't even say it's future. It's today.
Yeah, I think it's like 10, 15 years ago when handphone was like, huh, you got handphone now. What can you do with it? Now it's everybody has one and you cannot imagine yourself not having one. I think in the future, I mean the very near future, will be 3D printing everything. It's like, huh? You don't have a 3D printer at home? Then what do you do? You'll be so lost. So we don't need to buy all those casing anymore. We just 3D print our ideal phone casing, or maybe next time there won't be a phone. It'll be like, I don't know, like implanted somewhere. I don't know. It's very exciting.
Yeah.
So I'm really happy to see all of you here today. And it's 8:03. We can still wait a little bit more, right? Can we wait a bit more, Chris?
Yeah.
Can. Okay. So maybe 8:05, and then we shall start about that time. And in the last webinar, I was saying that we want to announce our new webinar series. But I'm sorry, we haven't been able to put things together because of COVID. Now everything blame COVID. But it's true that we haven't had the time to really get on the meeting with the library people. Did I mention this? Library? For those staying in Tampines, the Tampines Regional Library has a 3D printing lab. Ooh, have you ever been there before? So we are collaborating with them. Hopefully, not set up yet. Let's see. Hopefully, just stay in touch with us on the Tampines Home Farming Community Facebook page, and we will update latest news there. And for those who have not yet given us feedback on the feedback form, maybe I can put a link in the chat later. Give us feedback so we know how to craft the next series of workshops for you. Oh, I'm sorry. Kel, would you mind putting the feedback link in the chat, because I'm using a different computer, so I don't have the link with me right now.
Oh, okay. I'll use it. I'll do that. Give me a while.
Oh, thank you. Thank you. So for those who have not given us feedback, click on the link that Kel is going to put in the chat and let us know what we can do for the next series of webinars, which would be which would have a focus on 3D printing, on hands-on. Really, really hope that we can start meeting up and doing face-to-face workshops. And the amazing thing, I think, Chris, you got to tell us about the material that you use for 3D printing, because you told me before it's made of a material that is actually sustainable. Made from what? What is it made from?
It's made of corn and cassava. So it's the byproduct of processing those plants. So very sustainable. And once it's processed, it can be reused. Mm.
Yay! So we're making use of waste materials processed into the filament for 3D printing. That's fantastic. So we are at 8:06 now. Shall we start? What do you think?
Yep, we can start.
As usual, if you have any questions while Chris is going through the slides, just type it into the chat and we'll answer that. And I think we're going to have a very interesting demo later, right, Chris?
Yes, we will have.
Okay. So over to you.
Hey, thank you, Dorothy. Thank you, Kelvin. So, and thank you everyone for joining this 8th session of our webinar series for technologies in urban farming. So this is definitely not the season ender. We will just take a rest and sit down, check on what other programs that we can do for you, much more effective. Probably later in the year, we'll be able to do face-to-face classroom type on the facilities of OTH or probably NLB. So looking forward to that. So now our topic for this evening is 3D printing in farming. We in LifePlantz has been doing a lot of research and development with regards to 3D printing. So we have mentioned that our material that we have been using is called a thermoplastic material. So it can be melted and then put it into an object. So thermoplastic being melted, so the material itself is made from sustainable sources. So it's a byproduct of processing corn and cassava. So it's then processed into thermoplastic. So that's what we have been using. So if you have been asking if is it because you're melting plastic, so is this something like a harmful plastic for people or for the environment? Definitely not. As a byproduct of corn, it's definitely recyclable. But as any plastic recycling will do, it needs a little help from people. So you see from plastic bottles, they say it's like recyclable. But if you throw it in the sea, 10,000 years after, it's still a plastic bottle in the sea. So that is the sad part of doing thermoplastics or plastics in general, because they need a little bit of help from people to be able to recycle them. So how we recycle this product, so this material, is we put them back to its original form, which is the filament. So let's dig down a bit into 3D printing in farming. So let's define what is 3D printing. So 3D printing, otherwise called as additive manufacturing, is construction of three-dimensional objects. So it's a 3D, three-dimensional objects, three axes, X, Y, and Z. That is taken from a computer-aided design model. So we need a computer-aided design model of the objects that we will need to print. Later on, we will have a chance for you to explore a bit or probably try on designing a 3D object on your own. The process of constructing the three-dimensional object can be a variety of methods. So variety of methods right now, what you will see on 3D printing mostly is you melt a certain filament. So there are other things. So there are called like resin, so a liquid type of material where you punch in, where you put it on UV light, then it solidifies. So that is the first type of 3D printing. So we will cover it later on this. So it makes use of a resin and it's solidified by UV. However, it wastes a lot of materials that we don't or we rarely use of that particular type of or method of 3D printing. Another type that you will see is called the CNC. So we will also cover that later. CNC is a, a bulk of material, like a cube of metal, and then we drill on it until the object is conceptualized. That also wastes a lot of material, right? Because you have one cube and you just make a circle out of it, so all the excess materials are wasted. So having said that, the most effective way or sustainable way is by melting a certain filament. 3D printing is conceptualized in the 1970s, so not so long ago. The first prototype was on the 1980s, so it's stereolithography. So this is the method that I mentioned to you, the first method where there's a resin and a UV, ultraviolet light is used to polymerize or solidify the resin. However, though it makes accurate models, it wastes a lot of material. So it never gained popularity on the consumer side. Popularized in the year 2000. So we're coming nearer and nearer to 2020. So printers have been popularized in the late or the early 2000s into the general public. And the model that is very known right now is called fuse deposition modeling. So this is where you melt a certain material and go layer by layer until you form the object. So it's called FDM, fuse deposition modeling. It uses a continuous filament of thermoplastic material, most commonly known as polylactic acid. This is the material that I'm talking about earlier. This is the byproduct of corn, cassava, and any vegetable material that can be converted into polylactic acids. So polylactic acid is then processed further to become the thermoplastic that we're using. This thermoplastic is extruded in high temperatures. It will be about 220 degrees Celsius average to melt that particular material so that you can form it based on your CAD model or your 3D design. 220 degrees Celsius is quite hot, and it also consumes electricity. So from early 2000s to now, the printers have been very energy efficient. So there are technologies and ways how to sustain that temperature without consuming a lot of electricity. We drill down a bit on fuse deposition modeling. In 2004, a certain project was popularized by the enthusiasts of 3D printing. It's called RepRap, Replicated Rapid Prototypes. So meaning they're continuously printing prototypes day in, day out to produce something. What they have been producing is Groot. So from Marvel, No, just joking. It's the printer that is the actually printing itself. So you see those orange parts there, those are actually 3D printed. So now the RepRap objective is to make self-replicating 3D printers. 3D printing is a long process, like his there on the example. This particular model of Groot will take about more than 10 hours to print. So if you need like 10 pieces of it, if you have one printer, you will need to wait 100 hours to finish it. But if you have self-replicating printers where they replicate themselves or with the help of humans or robots, assemble them and then print based on what we need, then it can be completed in a short amount of time. This type of printers were popularized or made more available to the general public in 2009. 2009 is where the patents were released to the general public. You will see that sometimes patents tend to restrict the innovation of a certain product. And you will see the innovation only comes after the patents has been released. So patents protects intellectual property. So once the patent is released, then a lot of copies will be brought out into the public. So that's why it was made popular in 2009. 3D design tools. So Autodesk is the maker of AutoCAD. So they see the popularity boom, and they have made a platform for people to easily design without installing AutoCAD. So you can use an online tool, simple enough for you to produce 3D models. So they call it tinkercad.com. So it started in 2010. Later on, you'll have a chance to see, or if you have a computer with you, then you can do a registration and do the second part of this session with us. Let's discuss a bit more about FDM 3D printers. FDM's Fused Deposition Modeling 3D printer. How does it work? We'll see this diagram. The diagram here represents all the moving parts of your printer. It has 3 axes, X, Y, and Z axis. So X represented by this axis here. Y is this axis here, and your Z-axis is the up and down motion, which makes it 3-dimensional. So unlike your printers, HP printers or Canon printers, which prints on paper, so it's 1 dimension. Okay? They print on the X and Y without the Z-axis. So this one, they just made it Z-axis so that you have a 3D object. So those axes are controlled by stepper motors. Stepper motors is unlike your electric fan motors, which continuously rotate. So stepper motors has a step. So that's why it's called stepper. It steps. So one revolution is about 380 steps or 380 degrees of a circle, right? So stepper motors can step 1 degree, either this direction, clockwise, or counterclockwise, which makes it very precise. The precision of these motors is about 0.01 millimeter. So if you want to use your 3D printers for precision, yes, you can use it. So the positioner is where the axis meets. So there are stepper motors to control those axis movement on each of the positioner. The extruder is placed on the x-axis. So this is the extruder. So the extruder is comprised of the feeder and the hot end. Feeder is where the material is fed. The hot end is where it's melted. So it's a continuous feeding process to the hot end, X, Y, and Z axis moving. So it's melting, feeding, melting, and putting the melted plastic layer by layer. So we know the melting point of the plastic is about 220 degrees Celsius. So the hot end's temperature is average about that. Filament is extruded into also a heated print bed. So where your object sits on is called the print bed. So the print bed is also heated so that your object will not dislodge while you're printing. Remember that your X or your Y-axis, your print bed is also moving. So while it's moving, there's a tendency for your object to fall. So if it's a heated bed, it sticks to that bed. Let me show you some examples of 3D printers. So this is an example of what we use. This is one of our high-speed printers. So this is the x-axis. So you will see that this is the extruder, the hot end, the feeder, and the hot end. This is the filament, which is fed to that hot end and the feeder. Z-axis is this axis, and the y-axis is our bed, print bed. Another example is this picture. This is more of our, if we want accuracy on our prints, we use this printer. Though there are different brands and make, you will see common in the design. On the axis, on the print bed, even on the computer that controls those movements are basically the same. So that's why I said 2009, after the patent has been released, then there were a lot of copies already in the market. So two of those copies are these printers that we use. So the original one was made in the Netherlands by a guy called Prusa. So Prusa is the one who made the RepRap project, or the replicated rapid prototypes. I mentioned that 3D printing is also called additive manufacturing. And with additive manufacturing, your imagination is the limit. Creativity, right, is your weapon of choice. But if you're having a bad day, like not that creative, you can always go into online sources. One of which is thingiverse.com, which you can download 3D models. Later on, we're gonna check out Thingiverse. So you can download files based on STL file format or standard tessellation language. Standard tessellation language is like an object which is represented by tiles. So if you have a circle, it's not a complete perfect circle. Your circle is subdivided into portions of triangles to make your circle. You will notice that later on when we are using Tinkercad. So Tinkercad uses standard tessellation language as its file format. The file is then loaded into a software called Cura. Cura is a slicing software. Before you load it to your printer needs to understand what are you trying to print. So Cura converts this to another format which the printer understands. It's called a G code. So this is a computer numerical control, CNC. CNC, I mentioned, is another way for you to come up with a 3D object out of already a 3D object, like a box. This square, I want to make a circle out of it. So I program it to remove all of those edges and polish it in a way that it will be a circle. So that's a CNC. It just tells you which of the coordinates needs to be removed. Or in this case, where are the coordinates that it needs to have the material melted on. 3D scanners. 3D scanners has gained popularity because of the advancements on our smartphone. So our smartphone has sensors in the front. So it says camera. If you have an iPhone, you will be quite surprised that you can unlock using your face, right? So it doesn't unlock using the camera. It unlocks using the infrared sensor of your phone. Because you cannot unlock it using a picture. People tried unlocking iPhones using a picture. They cannot. Because your face needs to have depth. So it needs to have the contour of your face. Though the sensor that can do it is the infrared sensor. So it bounces a light on your face and it bounces back to the phone sensor. Then it can see what is the contour of your face. This is an example of a scan of a face. This is my daughter. So I scanned her face recently using an application. Later on, I'm going to show you how I did it. So it will just tell you, but unfortunately, I'm not sure if I think it just works on an iPhone because it needs the infrared sensor in the front. So it will tell you look sideways, to the left, to the right, up, down. Then it will be able to see or draw your face based on the picture that it took and the contour that it scanned using its IR. So this picture I loaded into our printer, and this is the final product. So we were able to print that scanned face of my daughter. Very nice. I was actually surprised of the quality of the print after, this was last week when I tried that application. So there are new possibilities, especially that we have a tool on our phones that can scan objects, 3D scan it. So once we 3D scan it, like, oh, I broke something. I broke a part of my toy. I want a new one. So you can scan using your phone, load it into the printer, and voila. You have the broken part now that you can, a new part to replace the broken part. Very nice. That's definitely the future of 3D printing. Additive manufacturing doesn't only encompass FDM or the fused deposition model. It can go to CNC, where you carve objects, stereolithography, where you use a resin. Now, even food, we can print food. Their printers can be modified to print food. So the similar, layer by layer, then you can come up with an object, a cake, something like that. Even a house, you will see houses being printed. So instead of plastic, so they put cement. So cement layer by layer until you have a house. In LifePlantz, we have been 3D printing most of our components. And it's one system for all and compatible to all LifePlantz kit. So LifePlantz have different kits, the start kit, the home kit, the advanced kit. So we have released in the public our start kit. So the start kit is printed on the pods, the stem, the cover, and the base. Some of you have received already this start kits. So the start kits are intended for you to start the germination process, micrograins. After 15 days, 20 days, you need to transplant it on either soil or on our home kit. LifePlantz uses a hydroponic or aeroponic system. So we use towers. So we also print these modules for our towers where you interconnect them and insert the pods. So this pods is inserted on this plant hose. So it's compatible. Yeah. So this is a picture of our home kit. So these are all available to you now. And the advanced kit will shortly come after. So the intended target for advanced kit is also the mass market, which is the consumer home gardening people. All right. So that is our first part. And we will go now to our second part of the webinar, which is 3D design. So let's start tinkering. Tinkering is a common term for us, like use your hands, tinker on things. Like if you like to tinker on your cell phone, you tinker like every day. That for if you are hobbyist, you tinker on like assembling toys, small toys. And if you are a gardener, you tinker on your garden every day. Tinkercad.com enables this creativity and is your go-to platform for tinkering. It's not only 3D design that is there. So there's also coding, there's also circuit. Later on, we'll see that. You can create your own design on Tinkercad. You can load STL files to modify it.
Oh, did we lose?
Yes.
Did we lose Chris? Sorry, guys. Did we lose Chris to technology, to AI?
Sucked into the matrix. Chris, where are you?
Yeah. Sorry about that, folks. Well, anybody until now has any question, you can still raise your hand. I'm here. I'm clone. Yeah. So I know today is much more about 3D printing technology. I mean, while we are waiting for Chris to come back, maybe I take this little opportunity to. Oh, Chris is back. I was about to say. Okay, can we hear you?
No,
Chris,
he's
we
on
can't
mute.
hear.
Can you hear
You're
me?
mute.
Okay.
Can you hear me
Yes.
now?
We lost you for 2 minutes.
Yeah. Sorry about that. So where did I stop?
Tinkering.
Sorry about that. I think my camera ran out of battery. So I'm going to use my front camera.
Battery.
It's already 8 sessions. I forgot to replace the camera. The battery. Sorry. So I stopped. Let me just do this. Let me see where I stopped. So I stopped here, right?
Yes.
Okay. So Tinkercad.com enables that creativity. You can use your own design, even edit an existing file, a 3D file, and you can import picture to convert it to 3D. And I will show you now Tinkercad. So this is the second part of our webinar. So let me just end the show. Can you still see my screen, the shared?
Yes, can still see.
Okay, let me just move this button. Okay. So I mentioned Thingiverse. So if you run out of ideas, creativity, so you can use Thingiverse. Thingiverse has already predefined or models that are available for you. So you will see popular things there like, oh, they already have the mask, right? Of the front man in the Squid Games. So if you want to download that, you can just click on it and you will see the 3D model, the front man of the Squid Game. So 3D models usually will be like this. So you can inspect the model by rotating it, yeah, and you can download it with the option download all files. So all these files in Thingiverse are usually free, though it will still have a license, right? So this is the this is what I've downloaded, Mr. Frontman. So the file will be an STL file, right? So you will see Frontman, Revolution, Rev 4, Revision 4. So this is our Frontman, right? So you will notice why are there like, what are this? What are these parts here? So remember that when we are 3D printing, there are overhangs that cannot be printed without support. We're, we're dealing with melted plastic and it's very loose, like jelly, like a jello. So if we don't support it, it will fall over and it will collapse. That's why there are supports here when you're printing. So that's Thingiverse. You can browse Thingiverse for different things, models, 3D models. And next will be our face scanner. So this is what I use to scan my daughter's face. So it's Bellius 3D face app. I'm not sure if it's available on Android. I've used an iPhone. Unfortunately, only iPhone 12 and above, if I'm not mistaken. Oh, 11. I have an 11, iPhone 11. So iPhone 11, they already have the IR sensor, which can bounce IR to your face to see the contour. So this is what the phone is seeing when you scan your face, right? So it takes a picture and it converts that picture into a 3D object. Very nice. So later on, you can browse Bellius 3D if you want to scan your face. And finally, we go to our Tinkercad. So Tinkercad is a product of Autodesk. So Autodesk is also the creator of AutoCAD. So Tinkercad now is more of a community free for use platform to get your creativity into 3D design, even circuit making, circuits, electronic circuits, and coding. So we will run through that, but not in detail. In detail, we will be going a bit in the basics of 3D design, right? So unfortunately, you might need to use a computer for this to enjoy the full features because sometimes it's hard to rotate objects when you're on a phone or on a tablet. So let's just join now. So it's easy to join. Just click on join now. Create a personal account. Let's say I want to sign in with Google. I have a Google account. So let's use one of my accounts. This one. Next. Next. Oops, it wants my verification. Very nice. So this is how they attempt to block any malicious content by two-step verification. So it will try to, if you're using a Gmail account, it will verify using your YouTube. Your YouTube will prompt you to authenticate. All right. So this is now the dashboard for your Tinkercad. There's 3D designs. There are circuits. So you can make electronic circuits and test them without actually having the physical circuit with you. Code blocks, you will be able to test code without typing if then else or print hello world. No need for that. So you'll just drag and drop code. Lessons, there are tutorial that you can watch. Let's see. Yeah, learn. If you click on learn, there are a number of options there, like in 3D design, teaching you how to place, how to view, how to move, how to rotate, which later on I will show you, or you can do it with me as we go along. And what is your next steps? When you have a 3D design, surely you need to 3D print it. So after this session 8, we'll be sitting down to see how we can deliver this next steps to you. Okay, so going back to the dashboard. So we will create a design. But before we create a design, let's try to set our objectives. So this is now mission possible. Your objective, should you choose to accept it, is create this. Wow, very complex. No, just joking. We will not make a complex pot for your plants. We will create an attachment to your hydroponic setup. So this will be a great start for the OTH kit people or the people that has the OTH kit, because one of the problems that we have seen or that you have highlighted is that the media is always very wet. So we would need to make an attachment to your hydroponic setup that will be functional and should aid on adjusting the height of your media pot. So meaning you can adjust the height so that your media is not fully submerged on your hydroponic solution. So this is the OTH kit, plant insert measurement. So we have a process called aggregation, which is actually estimating our measurements. So the OTH kit plant pot insert is about 48 millimeter diameter and about 48 millimeter deep. So let's remember that 48, 48. So that's what we will try to create, is a pot that you can insert on this plant pot insert so that your plant pot will not be fully submerged. Let me end this and go back to our Tinkercad. Right. So to start, you just click on create new design.
So when creating a new design, so you will see like some tips for you to go about. You can just close that now for now. So you will see the name. You can change the name of what you're trying to design as OTH plant hot. So this is your work plane. So your work plane now is 200 by 200 millimeter. So if you have a ruler with you, you can use that ruler to physically see a 200 by 200 millimeter work plane. But what we will do is only 48 millimeters, so we are quite confident that it will fit on our work plane. So I'm using an Apple MacBook. So I'm not sure if you have a mouse, if we can rotate this using your mouse. But if not, you can just click on this top, click on it, and then you can manipulate the work plane where you want to see it. Right? So if you want, if you lost it, like, oh no, I'm out. I don't know my orientation now. So you just click on home. So when you click on home, it will go back to its original position. So this is to fit. So let's say I accidentally zoomed in and I cannot go out of the zoom. You just fit it on your view or click on home. Then it will automatically go back to its original position. So this one is to zoom in, zoom out. So this one is for the flat view. So flat view is like top view, and this is the orthographic or the 3D view. Okay. So in here you will see just a bunch of like toggle notes. You can put notes and show all your notes. This is to group objects, to ungroup objects, which will later will go on. In this now, we will have your basic shapes. So our mission or our objective is to create a plant pot, like 48 by 48 millimeter, 48 millimeter in diameter, 48 millimeter in depth. So what we'll use? We will use sphere. No, sorry, a cylinder. Yeah. So when we drag that cylinder here, you click on your mouse and you hold it, left click, and you drag it. So it will drop that object on your work plane. So you will see your work plane. So it's not a perfect circle. It's a bunch of tiles, rectangles, joined together to create some sort of a circle. So you can create more sides. See, if I put less sides, 12 sides, you can eventually see that it's not a perfect circle. Once you make it more like 64 sides, it's almost a perfect circle, right? Perfect cylinder in this case. So now we have one part. We have one circle. What's our measurement? What's our diameter? So our diameter is 48. So we just put in 48 based on our duration estimating 48. So now that's our diameter. Nice. We have completed one part, which is the diameter. Now we need the height. The height is about another 48. So I put in here, this is the height. So when you click on your coordinates, it will highlight to you the measurements. Like if I click here, it will measure those sides. Since it's a circle, it needs to be the same, 48, 48. So if I click here, it will show you the same, 48, 48. If I click on this box here, it will show you the height. So our height should be 48. All right, so now we are almost there. So we have the height of our cylinder, correct, 48, and we have our diameter, which is 48. So what's missing? So this is just a cylinder. We need it to be hollow, right? Because we need to insert something on it. So to make it hollow, we need to drill a hole inside that cylinder. So how to drill a hole? How to make a hole? Right? So how to make a hole is we just drag in another cylinder. So this cylinder now, we just change the sides again so that it will almost be a perfect cylinder. So instead of making, this is 48, so we minus like 2 millimeters, 46, and 46, and our height be the same, about 48, right? So now we have a sphere which is slightly, we have a cylinder, sorry, we have a cylinder which is slightly smaller than the other one. So let's color this as another color. So if you click on this, it will change the color. Yeah. So now we have made two cylinders, one with 48 and one with 46, right? So I've shown you a while ago how to check the measurement. So if you highlight these boxes, you will see the measurement. When you highlight this, you'll see the height. So what is this? What is this triangle here? So when you click on this and try to move it, it will lift your object. So if I lift it, see, I'm now able to lift my object. Okay. So now let us not lift it for now. So let's make sure that it's 0. It's on our bed. It's on our work plane. Yep, it's on our work plane. So how do I make a hole using this second cylinder? Right? Because if I put it, I'm just making another cylinder within a cylinder. Right? So to change the configuration of this cylinder is you just click on hole. So now this will make a hole out of your object, your first cylinder. So how do I make sure that it is in the center? It's very hard to make sure that it is on the center, because if it's not on the center, it will look like something else. So to make sure that it is on the center, you just select by clicking your mouse, left click, select all of your objects. This option here is to align. So when you click on align, you can now align it based on where you want to put it. For us, we want these circles to be in the same center. So when you click this center and this center, it will make your two circles on the same point, right? Okay. So now, almost done. There's one more thing left to be done, is to group this two together. So again, I'll left click and select all of my object. So when I select all of my object, I will click on this option here, which is to group. So when I group them, So they will now be, so now we have your object, your pot with a hole on it, right? Very nice. So now this one you can insert on your OTH plant pot inserts, and you can make this higher, right? So that when you place in your plant pot, it's not fully submerged. Even though it's very simple, 2 cylinders together, it's functional. So that's what we're trying to promote here in Tinkercad. It's your imagination. So let's say I want a hole. I want another hole on it on the side. So you can just drag another. Oh, there's a hole there, yeah? Cylinder, okay? You can just drag another cylinder, make sure it's a hole. You can rotate objects. So you can also see that there are like this arrow here to rotate. So you can rotate objects. So you can rotate it 90 degrees, right? Then you can lift it up. Then select all your object. Make sure that it's center. So center means here. And I want it a little bit more here. So I select again and click on align, center, select all of my objects and group. So now you have a cylinder with a hole on the side. So these are like things that you can do. Try to like change, put a square on it so that you see the result of what you're trying to achieve. So it's very nice. This particular product, Tinkercad. So it's an online, purely free. So you can explore. You can do a lot with this platform. Okay, so from here, you should be able to start your journey into 3D designing, register on Tinkercad. Try this exercise, doing a cylinder, which is a hole, a cylinder, which you can use as a functional equipment for your OTH kit. And you can also go back and do the lessons. So there are there are lessons there. See all. So there's a lot of lessons. Some basic stuffs that you can do. And once you have learned all of those, like duplicating it, copying it, then you're set. Your imagination is the limit. Creativity pushes your creativity. So that's all for today. I hope that we have introduced you 3D printing. And as a starter, you can, if you don't have a 3D printer, as a starter, you can go to Tinkercad and tinker things, create models for you to get familiarized on how to create a 3D model. It's very easy on Tinkercad. Hopefully, when we are able to make use of NLB facilities, they have a printer there, then you can visit OTH, the library there, to load your printer. your model. Let me see how you export it. Sorry. So let's go back again and open your model. So once you have your model ready, you just export, right? Click on export. Remember, our file is STL. You can also use OBJ, but OBJ is more proprietary for AutoCAD. So once you have downloaded it, let me just try to find where is it. Downloads. Yep, this is our file. So when you open your file, so this is your model, right? So STL, tessellation, meaning your object is sliced into multiple slices of tiles to create the object. So you will see definitely that there are tiles of squares there. Okay. So this is the file that you'll bring to your 3D printer or your slicer software, which is Cura. So hopefully that this will get you started into your 3D printing journey. So not only for farming, but you can also use it at your home. So we have been printing quite a number of like even spoon, fork. You can print your plates. Sky's the limit. So thank you very much. So now we spend some time in questions.
Thank you, Chris. Looking at the chat, Willie had a question and Kel already answered it just now. So for those who haven't been looking at the chat, Winnie was asking about the hydroponic setup, how long it took to print, and Kel answered that it takes about 6 hours to print each pot, and each machine can print 5 to 6 pots within the time frame. And Whitney, it seems that she has made use of the lab before. The make it. Okay, actually, I give you some background. The lab, the 3D printing lab, used to be called Pixels Lab at NLB, and then later they rebranded it to Make IT Lab. But we always call it the official name is Make IT at Tampines. There are 3. One is at Tampines, Jurong, Woodlands. Official name is Make IT at Tampines, but we always call it Make It at Tampines. So, Whitney, maybe could I invite you to unmute yourself, and would you like to share with us your experience using the lab? You have used the lab before?
Hi.
Hi.
I seen you the other day at OTH.
Oh, you did?
Okay.
I probably didn't recognize you.
Yeah, you won't recognize me. Anyway, you're busy eating. Okay. Actually, it's quite a good place to make yours. That's why I was asking about how long it takes to print out that setup kit, because at the make it you only have a booking of 4 hours, so you cannot print it over there. Then you can only book the session to make use of the printer if you are certified, like as I mentioned. But if you attend a starter session, there you are actually certified already. So it's actually a very popular place. Every time I went there, it's like all the printers are being taken up. So you have to book in advance.
How many printers are there?
I think there's 4. And the filaments there are free also, but you have to account for it now.
How many times have you been there to print things?
I went quite a few, but because of COVID time, sometimes they just close it, so I'm not able to do it. Just to show you what I've done it before. Just this simple box. I use 2 sessions to print.
Oh,
Yeah.
that means you have to
Yes.
split it into 2 days, 4 hours, 4 hours.
Yes, correct. So the other thing is Chris is very good with his teaching. So then the thing is that but if you learn it through here, you are not satisfied lah. So I don't know if you have if you collaborate with them, whether the people that learn through it will be certified or not. Then it's quite fun. The Thingiverse, if you have no idea what you want to create, that is really a very good place to go through. And after learning this, I find that there are so many things that you can print, those that everyday stuff, hook, everything. It's really fun.
So when you're there printing, is there someone supervising you, or you can just use the machine?
Because you already learn, so we can do it ourselves. But there's always someone there to help you if you are not sure about your things or this. But one thing you need to know if you take things from Thingiverse is that you may need to adjust the measurement, because like what I showed the box, the ribbons on top cannot actually fit in. So I have to ask for help. Then he gave me a better idea by burning the bottom and then fit it in. Because I was like spending so much trying to saw it to find ways to fit it in. So there are always people there to help you, to guide you actually.
Yes, I think for sure when we collaborate with NLP, I think they would include that certification process in the workshop.
Then the other thing is Tampines is a very popular place to go. So previously, there's one session I spoke to the supervisor. He was telling me Woodlands or is it Jurong? Cannot remember. Not much people there. So if you all really are interested to print things, you all don't mind so far away, you can go that area.
Or we lobby Tampines to buy more machines.
Oh, the machines there are actually quite old. So some of the things when you print out may not be so nice.
Okay. So maybe, Chris, when we meet the library people, you can suggest to them to buy new machines.
Yes, definitely.
Because it's so popular, so it has been being overused, maybe.
Very well used lah.
Yes, correct. Well used, that's the word.
How did you get started? What made you interested in going there and learn and start 3D printing?
I went and walked by a few times, so I was looking at people doing it, so I was interested, so I checked it out. And at that time, it was not open yet. So the person in charge was telling me about it. So I keep a lookout when the starter sessions open up to learn. And it's actually quite fast. People grab the session.
Are you planting anything at home? Are you using hydroponics?
I'm trying, but I don't have green fingers, as I said a long time ago. So not successful many times.
Okay, so try again. Rewatch our webinars and see whether you can try again.
I'm trying.
Okay.
I'm trying one that I bought online, some simple those DIY kits. So don't know whether successful or not. Still germination.
Okay, if you have any questions, can just post inside the Facebook group page and we'll see whether we can help you.
Sure. Thank you.
Thank you for sharing. Thank you very much. Are there anybody else in the group who has, because I see some familiar names who are part of the OTH hydroponics pilot program, and I know that some of you actually have used 3D printing to improve the system, but I can't remember who. Already memory not very good. Are you here? Is anybody of you here from the OTH pilot program, or even not from the program, but you have tried using 3D printing to improve your hydroponic system or any planting system? No? Okay, so you are prime candidates to join our next webinar. So we see that I don't think we have any questions in the chat. Anybody have questions you want to ask? Go ahead and come and unmute yourself or type it in the chat right now. Or where is this place? It's inside the library. So Xia just asked where is the lab? It is inside the Tampines library. For those who have never been to the Tampines library, come to OTH, go to level 2 and look for the library, or go to the information counter and ask for the library and ask where is the library. It's a very big place inside. It's fantastic. Just go and explore. And once you're inside the library, you can ask the librarian, where's your 3D lab? I don't think they're open now because of COVID, but go and explore. All right. So, Chris, Kel, anything from you guys? I think there are no questions in the chat. Maybe they're just, Winnie just added that the lab is at level 4. Thanks, Winnie. So I think today's lesson being more new, people still don't know what questions to ask. Anything else from you before we close it for the night?
You're on mute.
Anything? Sorry, I'm on mute.
Kelvin, on mute.
Okay, hi. Since this is the finale session, I take a bit 5 to 10 minutes of your time. So today's lesson is very much about 3D, everything 3D technology. So just to recap, we have learned about lights, we have done bugs, we have done medium, we have done water. So raise of hand if you like to visit our little working area. I'll just bring a quick virtual tour. Anybody?
Virtual tour of your work area.
Yeah, I'll where Chris work. So I'll bring everybody on a short quick tour since I'm here. So what we had learned today, 3D printing. So if you can see right here, these are all actually 3D machines. So what Chris talked about earlier, these are the pods. So what Winnie asked about, how long does it take? So it also depends on the size of this machine. So if your size of the machine is bigger, you can actually build much more pods at the same time. And of course, if your pods are much more lower in height, it takes less time. So all these are really subjective to what is being required to build on. So what LifePlantz is trying to bring to everyone right from first webinar, of course, we would love to bring this whole thing to OTH library. That's our wish. So we can see you guys and actually really what we have been working on. So I hope you guys are not dizzy. So we are using technology. Right here, we are using technology. All the lessons, all the webinars we have been through about lighting. Water, so we're using sensors. These are all very much Chris' work. Chris, you there?
Yeah, I'm here. They're nice.
Yeah.
Nice tour.
Yeah. Nice. So this is very much Chris' work. So I'm much more of a gimmick marketing guy. So this is what we hope to bring to OTH library. So using 3D technology, using algorithm, using sensor, how to control the lights, water, nutrient, growing medium. So growing different kind of plants. So we hope to see you, really hope to see you at Tampines in person. So this 3D printing and technology, we can actually bring to all of you live. So even what Chris showed earlier, like what Chris is building. So it may be fun. So what we had went through just now is about 3D printing. So planting is so fun that we can actually make this into a vase, into something that you're growing plants out of it. It could be your child's face, your own face. it could be an animal, it could be something you like. So we really hope to bring all this to you. Yep. See you all in Tampines soon. Dorothy, back to you.
So thank you very much for following us all this while. And for those who are Tampines residents who sometimes come to Tampines, and if you see me walking about, if you recognize me, please say hi. I won't be able to recognize you because you have got your mask on, and I am not very good with remembering faces. But please do say hi, and we'll see you very soon. So thank you, and thank you. Thank you for the tour, Karen. Thank you, Chris, for the wonderful webinar so far. So we are looking for technology in home farming 2.0 soon. Thank you, everyone. Good night. Good night.
Night. Thank you, everyone.
Bye. Bye.